Hello students, I am Dr. Tanmoy Biswas. So today we shall discuss one MCQ about this multiple step reaction in front of you. So we have to say what is the major product at the end. 4 options are provided. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box. Don't hesitate whether your answer will be right or wrong, because self-evaluation is essential for improvement and I want to know your logic. That's why you should write few words along with the answers. I believe you have tried by yourself, so it's my turn to give you the right answer. But before going to details, I suggest you student, these reaction, there are 3-step reaction, okay, and this molecule is pretty big. So here the key point is, first look at what is the molecule and what first step is asked. In the first step, if you look at, this is actually an iminium salt. So this is electrophile, and electrophile where? Electrophile is this carbon. It's a very less bulky, fine. And if you look at that, here TEE is giving. TEA means triethylamine. So we know that this triethylamine are specific proton scavenger, or it's a very selective base, means proton obstructing agent. So it cannot act as nucleophile because of 3 ethyl groups attached to the nitrogen. Now, so that stable attack means as nucleophile not possible, it can act as a base. So where the acidic proton is, if you look at these 3 carboxyl groups are in ester form, so not possible. Others are either ether, means this is ether, and this is actually protected, means acetal. All are base stable because acetals undergo hydrolysis in presence of acid, but they are stable in base. So reaction not possible here. But one point is there, student. If you look at this side, this is active methylene group and there is 1 proton. We know that the carbon ion from this active methylene group is, student, stabilized. Why I am saying it's stabilized? Because here this is OMe and the carbon ion is here. It is doubly stabilized either by this carbonyl here, means you can see this, and similar stability is possible for other group also. So that's why the pK is significantly low for active methylene compounds like 9 to 11. And this is, you can consider, derivative of diethyl malonate, which is capable to undergo deprotonation in presence of mild base like triethylamine. So this is the first and foremost important point. So here after this proton abstraction, a carbon ion will be produced, and carbon ion can act as nucleophile, and that nucleophile can attack these electrophilic center or carbon center. And if you look at very closely, student, this center is very less bulky because 2 attached things are hydrogen. So based on the principle Bargi-Dunich trajectory or Burgi-Dunich trajectory, this nucleophilic addition is favored. So let's learn everything stepwise. So first, here in presence of this base, it is carbon ion generation, and this carbon ion attacks here because very less bulky, these 2 are hydrogen, okay. So nucleophilic attack will happen here, it will open up and ultimately it will produce these amine. And if you look at, student, this is actually a tertiary amine and it has a lone pair of electron, and these lone pair of electron can act as nucleophile. And in the second step, methyl iodide is given. It's a very good electrophilic reagent and this attack is possible. Methyl group very less bulky, and iodide is also a good leaving group, so it will leave and ultimately produce, this is a quaternary ammonium salt. Okay, and we know this quaternary ammonium salt are stable, fine, and counter anion is iodide. Now this iodide is actually, student, good nucleophile, very good nucleophile and very good leaving group both. So what it can do in the next step, it can act as a nucleophile on this methyl group. So if it attacks, it goes here. So in the first stage, what is produced? Methyl iodide. It comes out from the reaction medium, and where this lone pair of electron comes and it produces carboxylate, and these can undergo further reaction, means it can push here, it will open, come back, and it will come here, these nitrogen leaves. It's, I know, long step, so let's understand this stepwise. So first step is, student, this part is decarboxylation. Fine, carbon dioxide will come out. And second step, it's an elimination, means it comes and this part leaves. Why? Because the leaving group is trimethylamine here, and this is, student, a neutral leaving group, because previously the nitrogen was cationic, and right now after this leaving it's neutral, and neutral leaving groups are stable. So based on this decarboxylative elimination procedure, ultimately it produces a double bond. Okay, you may compare this concept with Hofmann elimination reaction. So this is the overall reaction. So what are the key steps for and name reaction associated here? First step is Mannich reaction, and here more specifically it is Essen-Moser salt. Okay, I've already discussed or dedicated many dedicated lectures on this Mannich reaction, and one dedicated on Essen-Moser salt. And second is SN2 reaction. I've already discussed many lectures. Here the nucleophile is bulkier, means means you may say tertiary amine, so electrophile is weaker, and the leaving group is very good. Third, it is decarboxylative elimination initiated by nucleophilic addition. So it's many reactions are there, and because of this good nucleophilicity of iodine, this reaction starts. And remember, student, when from one product to many products are produced, and for that purpose obviously heating is essential, I've mentioned. So this reaction is also favorable entropically, because delta G is equal to delta H minus T delta S. These molecules are stable, so enthalpy wise this is also delta H negative. And if you look at from one molecule, many molecules are produced, so delta S is highly positive. Okay, and T is relatively higher, so delta G is very much negative. That is the condition of spontaneity of this reaction, and ultimately it produces this alkene as product. So here the product will be produced. Now what is the product of this alkene? Alkene with, student, one carboxyl group elimination. So option C is the right answer. Now if this question is asked in your exam, how can you conclude the right answer less than 30 seconds? For that purpose you need to be little fast to understand the reactive center. What is asked in the first step, as I told, this is electrophile, this is base, DCM as solvent. So triethylamine is a base where the acidic protons are there, obviously here, because it's an active methylene group. So from this thing you can clearly conclude that reaction will happen and no acid is given. So this acetyl ether, no, not possible. So if you just understand this much, so the option B gone, because it is actually hydrolysis of this acetyl, not possible. Now another thing, option A and D, if you look at this, A is no reaction, no, student, reaction will happen, this is gone. And what is this? Now option C and D is remaining. Next step is, student, methyl iodide and heat. So methyl iodide means, student, actually this nitrogen will be quaternary formation and elimination. See, if you know the concept of decarboxylation of beta keto acids, I've already discussed, one carboxyl group is eliminated, only one can leave. How two possible? Second thing, here I have written CH3. So carboxyl group is reduced to CH3. For that purpose a strong reducing agent is needed. Did I provide any reducing agent here? No. So based on logic, this is also gone. So what is left? This. So in this way, based on your understanding, you can come up to the right answer. But for that purpose, first study and second practice is essential. So in conclusion, what you have learned today, that imine is actually a very good electrophile, fine, but its electrophilicity further increases when iminium ion is produced, because you may consider that this is actually a imine, fine, and if you make it a iminium, means one, this another, this is cationic. So because of this positive charge, the electrophilicity at this carbon increases, so it becomes a better electrophile. So obviously reaction rate enhances, and active methylene compounds can undergo deprotonation easily because the produced conjugate base or carbon ion is doubly stabilized. So it is stable, and second, carbon ion is actually a softer in nature, so it can act as nucleophile too. But for this purpose, you need to know that in this case the nucleophile means this carbon ion from active methylene compound is little more bulky. So if so, the electrophile should be very less bulky to have a smooth SN2 type reaction. Okay, and the elimination, which is this Hofmann elimination reaction, could be achieved in presence of base or heat, but quaternary ammonium salt is needed. And finally, this decarboxylation reaction is entropically and enthalpically favorable process because heat is produced and from one molecule to many molecule produced, so both point stable. And finally, the ammonium moiety can act as a better leaving group, as the leaving group is neutral, means trialkylamine, and neutral leave means neutral part leaves with stabilization. Okay, so this is the end of the discussion. I believe this video may be useful. Please write your opinion in the comment box, and if you consider my contents are worthy, then please help this channel to grow. So thanks for watching. See you in my next video. Bye.